So as you look at lesson 2.7, notice it's solving equations in one variable, and notice it says extraneous solutions. Do you remember what the word extraneous solutions means? Okay, extra solutions that don't work. Okay, when we talk about these problems today, we're going to want to be on the lookout for extraneous solutions. Solutions that we legitimately come up with as answers, but then when you put them back in and check them, they don't actually work. And as you look at all four of these examples we have planned out today, all four of these examples have fractions. And more importantly, they have fractions that have variables in the denominator. When you start having fractions where there's variables in the denominator, that's when you're going to create extraneous solutions. Now, that doesn't mean every problem has extraneous solutions, but some of them will. And that's what we want to be on the lookout for. So I'll talk about different ways as we go through today that we can check our answers and give us some ideas there. Let's look at example 1. X plus 3 over x equals 4. Any thoughts of how to solve? I don't want to get a same denominator. How about we get rid of the denominator? How do we get rid of a denominator of x? Multiply by x, right? Because if a fraction is being divided by x, the opposite of dividing by x is to multiply by x. If we're multiplying by x, that means we're going to multiply the entire left side by x and the entire right side by x. I just started to write the wrong thing, though. So on the left, when we multiply by x, keep in mind we're going to have to take that x and we're going to have to distribute. X times x is x squared plus, how do we multiply x times 3 over x? Yeah, it just becomes 3 because you can think of the x as x over 1 if you need to. X over 1 times 3 over x, the x's will cancel, and it just becomes 3. So x squared plus 3 on the left. On the right, 4 times x is 4x. Okay, the question in class, are we going to equal this to 0? Would that be a good idea here? Yeah, based on the fact that there's an x squared term, an x term, and a constant term. We want to think about making this equal to 0. So how am I going to make this equation equal to 0? Okay, by taking over the 4x. So if this is a positive 4x, we want to subtract 4x. If I subtract 4x on the right, subtract 4x on the left. What's a good way to rewrite that left side? Okay, x squared minus 4x plus 3 equals 0. So now we've got ourselves in that format of x squared plus bx plus c equals 0. Thoughts on what to do now for solving? Factor. We're going to hope we can factor, right? Let's see, is there a GCF? No. We're going to hope it can factor into 2 parentheses. X squared breaks into x and x. I need 2 numbers that multiply to be 3 and add to be negative 4. Okay, yeah. It's a combination of 3 times 1 and 3 plus 1. They multiply to be positive and add to be negative. They're both negative. So x minus 3 and x minus 1. Once you've got it factored, set each part equal to 0. So x minus 3 equals 0. X minus 1 equals 0. And we get solutions of x equals 3 and x equals 1. how do I check this? Okay, so in this one we're going to do what I would call an algebraic check, which is the basic check that we often think about, and that's where you just plug them back in. And I'm actually going to write it out just for a visual. Am I saying you have to write your checks out today? No, I'm not. Okay, you're welcome to always write a check out, but you can always do checks in your head. That is fine. So in this case, if we're going to check algebraically, just take turns taking your two answers and plugging them back into the equation and make sure they work out, correct? So if we try 3. Now, when I say plug them back in, make sure you plug back into the very original equation. Do not plug it back into what you got after you multiplied by x, because you've changed the value of the equation then. So if I plug in, what's my first one? 3. So 3 plus 3 over 3 equals 4. Does that work? Yeah, because it becomes 3 plus 1 equals 4, which checks. We also want to plug in 1. So 1 plus 3 over 1 equals 4. Does that work? And it does, because 1 plus 3 is 4. And so in this particular example, both answers work. Excuse me. Okay, questions on that one? Okay, let's try example 2 then. What are your thoughts on example 2? Okay. This time we have a denominator of x minus 4. And so how do we get rid of a denominator of x minus 4? You multiply by x minus 4, which is fine. We can do just that. Just like up above, we were multiplying by x. X was the factor in the denominator. This time, it's x minus 4. So I'm going to multiply both the left side of my equation by x minus 4 and the right side of my equation by x minus 4. Again, you can think about it as x minus 4 over 1 if you want to think as a fraction. How do we multiply x minus 4 times that first x? Okay, it's going to be a distribute. And I'll write it down both ways. You can start off by thinking of it as x times x minus 4. If you want to skip that and go ahead and distribute, when you distribute this, it would become x squared minus 4x. Okay, plus, what happens when you multiply x minus 4 times 1 over x minus 4? Yeah, x minus, the whole idea here is x minus 4's cancel. You're left with 1 over 1, which is just 1. Equals, what's 0 times x minus 4? 0. Okay. Again, I kind of wrote out two equations there just because I wrote x times x minus 4 in the first one, then I distributed in the second one. You're more than welcome to go ahead and distribute right as you go into it. Okay. Now what? Okay, so first of all, notice we have it's x squared plus bx plus c, and it already equals 0, yes? Did you try and factor? We want to factor, don't we? However, the problem is, are there two numbers that are going to multiply to be 1 and add to be negative 4? And unfortunately, the answer to that is no. So, with that in mind, plan B is quadratic formula. Aren't you so glad I played the song for you just last week? Okay, here we go. X equals negative b. So what's negative b? 4 plus or minus the square root b squared. So negative 4 squared minus 4 times A, which is 1, times C, which is 1, all over 2A, or 2 times 1. Okay, clean it up. 4 plus or minus. What do we have under the square root there? Negative 4 squared is 16. Minus 4 times 1 times 1, so 16 minus 4 is 12. So 4 plus or minus the square root of 12 all over 2. We don't want to divide yet. Yeah, we need to worry about the square root of 12. The square root of 12 has a perfect square in it of 4. So since we know 12 is 4 times 3, but the square root of 4 is 2, so that 2 goes outside the radical. And so it's going to be 4 plus or minus 2 square root of 3 all over 2. Does that sound familiar? Now I'm ready to talk about dividing. And that, what do you notice? All 3 pieces have a 2 in common, don't they? So everything can divide by 2. So 4 divided by 2 is 2, plus or minus. What about 2 radical 3 divided by 2? Just square root of 3. And then it'd still be all over 1 if you want to think that way, but I would just leave it like this, 2 plus or minus the square root of 3. Thoughts about checking this one? She'd rather not. I don't blame her based on how do we normally check an equation? You plug it back in, yes? And I don't blame you for not wanting to plug in 2 plus square root of 3 and then 2 minus square root of 3. Okay. We're going to talk about a different way to check. What's another way to check other than algebraically and plugging the answer back in? Graphically. How can we check this graphically? Yeah. If these are truly solutions, what are these on the graph? Your x-intercepts, your zeros. So how can we check this graphically is to graph it and check and see if these are the zeros, if these match up with the zeros. Now, obviously, is my 0 going to come up as 2 plus square root of 3 on my calculator? No, it's going to come up as a decimal, so we're going to have to do a little work here. But in all honesty, I still think it's better than having to plug this in. So, okay, so let's look at what checking this graphically will look like. So first thing, when we graph this, notice my equations start off being equal to 0, didn't it? So when we graph that, basically you're just going to do y equals the original equation. And then graph it. So we're going to graph y equals x plus 1 over x minus 4. After you graph it, you're going to want to look for your zeros. Okay. So y equals x plus, I'm doing my fraction bar, so 1 over x minus 4. If you can't do a fraction bar, you must put the x minus 4 in parentheses. I'm going to do a zoom 6 because I don't remember what I graphed before Thanksgiving. Okay. I did. But if it wasn't for when I graphed this second hour, I'm like, I have no idea when I last graphed. So, yes, I did graph it second hour. But for you guys, that's what you're probably thinking. Okay. Zeros, do you remember how to find zeros? Second calc. Number 2 is 0. Left bound, right bound around those x-intercepts, right? And I have a 0 of 0.26794919. I'm going to write that down for the moment. Or you can go and check and see if that matches up with 2 plus radical 3, right? I'm just going to write it down for a moment at 0.26, I'll run it to 0.268. I'm going to check my other one, second 0. Left bound, whoops, right bound, and 3.7320508. So approximately 3.732. Now I'm going to go out on my graph and I'm going to put it in my calculator. Okay, let's see. What is 2 square root of 3? Hey, guess what? Does that number look familiar? 3.732050808. And I'm going to do the same thing. What's 2 minus square root of 3? 0.267949194. Matches right up, doesn't it? So, does this check? Yeah, it does. Those match with that, and so, yes, these are both solutions. Okay, questions so far? Okay, let's try example 3 then. What are your thoughts on example 3? Okay. Okay, so if you look at the first side, x minus 1, x minus 3, we have 2 different denominators there, yes? And then it appears we have a third different denominator. However, I will always say, always get your denominators factored before you decide what you're multiplying by. Because what do you notice about x squared minus 4x plus 3? It factors into x and minus 1 and minus 3. Because minus 1 times minus 3 is positive 3. And negative 1 and negative 3 adds to be negative 4. Okay, that's not just coincidence, folks. That is by design. And this problem would be a lot more difficult if that didn't happen. Because as we look at what we want to multiply by, we have to multiply basically like if we were getting one big common denominator. That's what we need to multiply by. So any factor that's in common, or any factor that's used in the denominators. So what factors do we use? X minus 1, x minus 3. And what's used here? X minus 1, x minus 3. So what are we multiplying both sides of the equation by? X minus 1 and x minus 3. Okay, you ready? In the first fraction, it's x minus 1 times x minus 3 times the fraction 2x over x minus 1. What happens with that first fraction? X minus 1s will cancel with the first fraction, and what remains? 2x times x minus 3. Okay. I'll come back and deal with that later. Plus, second fraction. What happens with the second fraction? This time, x minus 3 cancels, and what remains? X minus 1 times my numerator of 1. So 1 times x minus 1 equals. What happens on the right-hand side of the equal sign? Oh, x minus 1, x minus 3, cancel. Leaving me with what? 2. Okay. What would you like to do to work on solving this? Distribute. So when I distribute, I have 2x squared minus 6x plus x minus 1 equals 2. Okay, so 2 steps that need to happen, and I'm more than willing to do them both at once. Add like terms together, and go ahead and make your equation equal to 0. So to make it equal to 0, I'm going to subtract the 2 over. So 2x squared minus 5x minus 3 equals 0. Okay, what's your plan now? Okay, so, yeah, it's going to go that direction. So we can try factoring. Keep in mind, it's not just product and sum. It has to be product of AC. Okay? If product of AC fails, or if you don't want to attempt product of AC, what's your backup plan here? Quadratic formula. Okay? And could you go ahead and go straight quadratic formula if you wanted to? You can. Now, I'm going to take advantage of an opportunity to review product of AC because I know some of you need that. There's always people that need that. So when I say product of AC, that means product of 2 times negative 3 or negative 6. And a sum of the B term, which is negative 5. What multiplies to be negative 6 and adds to be negative 5? In order to get the signs to work out, you have to use 6 and 1. Because I need opposite signs, since it multiplies to be negative 6, and then it has to add to be negative 5. So I'm going to use negative 6 and positive 1, right? So take that middle term and split it into minus 6x plus 1x. Or if you prefer it the other way around, you can. Still carry down the first term of 2x squared. Carry down the last term of minus 3, and it equals 0. There's 4 terms. So split them in half. What's GCF of the first half? (2x). So if I factor out 2x, I'm going to be left with x minus 3. GCF of the back half. Yeah, if all else fails, there's always a GCF of 1. You have to put something. So I'm going to say plus 1. And then when I factor out a 1, there's still x minus 3. Okay. 2 parentheses. One of the parentheses comes from your GCFs of 2x and plus 1. Other parenthesis comes from matching parentheses of x minus 3. Set each part equal to 0. 2x plus 1 equals 0. X minus 3 equals 0. Subtract 1, divide by 2, and x is negative 1/2. Add 3 and x is 3. Now, one last thing, and that is we need to check for extraneous solutions. Now, I just realized in your class I forgot to mention something. I don't know if anyone will come up with this since I didn't mention it to begin with. I'm going to do a third different way to check this one. Look at your original problem. What do we know about denominators? What can denominators never be? Denominators can never equal 0, correct? Just not possible. What do you notice about one of my answers? If I put in this 3 in this denominator right here, what's it going to do? It's going to make this denominator equal 0. Is that possible? No. So guess what? Does 3 check? No, it does not, because it would make my denominator equal 0. Now, what's the other number that would not check? 1. What's the answer I have? Negative 1/2. Guess what? If we went through the check and worked it out, negative 1/2 is going to work. Okay? This is a really good way to check things today. I know I took the other routes and I reviewed algebraic with you, I reviewed graphically with you, but this is overall the best check that's going to work. Is look for anything that can make your denominator equal to 0. Those are the answers that won't work. Okay? So like if we scoot back up to example 2, what answer would not have worked here? A 4. We didn't get a 4, so we probably would have known they worked. If I go back up to example 1, what answer would not have worked here? A plain old 0. Okay? So we would have known that the 3 and 1 probably work. Okay? So be on the lookout for those. Those are going to be the big ones that don't work, is anything that will make your denominator equal to 0. Okay? Okay. One more? Might be able to get through it in your class. I at least want to talk about some highlights of it regardless. Okay, so check out these denominators. I've got a denominator of x, denominator of x plus 2. What do you know about x squared plus 2x? Oh, it has a GCF of x. And so if I write this in factored form and factor out GCF of x, what's in parentheses? X plus 2. Again, not just coincidence, right? It's by design that x times x plus 2 matches up with other denominators. You want it to, because otherwise you have that much more you have to multiply by. So, what am I multiplying both sides of the equation by? Okay, my common factors or common denominators of x and x plus 2. X plus 2. So I'm multiplying by x plus 2. Okay, piece by piece here. I will scoot that up some. Because I know when I get low virtual, there tends to be a glare. Okay. X plus 2 times x minus 3 over x. What happens? X's cancel, and you'll have x plus 2 times x minus 3, correct? Okay, plus second fraction, 3 over x plus 2. What cancels? X plus 2 cancels. What remains? 3 times x. Okay, plus last fraction. What cancels? X and x plus 2 both cancel. What remains? The 6 that's on top, so plus 6. Equals on the right. What's 0 times anything? 0. Okay, good news is it all already equals 0. I need to do with x plus 2 and x minus 3? Distribute or FOIL. So if I multiply those together, x times x is x squared. Outsides, net minus 3x. Insides, 2x. So minus x. Last, 2 times minus 3 is minus 6. Plus 3x plus 6 equals 0. Clean it up. What do I have when I clean it up? X squared plus 2x equals 0. Now what are your thoughts? Can we factor it using GCF? Yeah. There's no C term, so product and sum isn't going to work very nicely. But GCF, both terms have an x in common. So when you factor an x out, we're left with x plus 2 in parentheses. Set both parts equal to 0, right? What is the first part I'm talking about saying equal to 0? X. So x equals 0 and x plus 2 equals 0. What's that make my solutions? 0 and negative 2. And as always, we want to check them. What happens when you try and check these? Okay. 0, if I put 0 in for x right here in the first fraction, it makes that fraction have a denominator of 0. That doesn't check. That's not an option. What if I put negative 2 in? Negative 2 plus 2 in this fraction right here gives me 0. What just happened? No solution. And that is possible. Neither solution worked, so no solution. And the key is that neither solution worked in the denominator. And I'm going to write a little note up here in case anyone looks later. Neither solution works in the denominator. Okay, your homework is on page 232, 4 through 28, evens, which if the math teacher is doing her math right, I believe that should be about 13 problems. Okay, be sure to be checking your solutions.